Dear viewers, welcome to our lesson. We are back science education consultants, and we are here to provide a series of lessons that will keep you active. From wherever you are, just go to our YouTube channel and subscribe to keep notified of whatever we produce for you. Visit our YouTube channel, Back Science Education Consultants. You will find there a number of services that we can offer to you from wherever you are when you are safe. Remember, COVID is real, and make sure you keep safe. Today, we are going to start from our previous lessons, and we now move to more specific objectives. By the end of today, you should be able to appreciate that actually electrolysis occurs in electrolytes, which are either in molten form or in solution form. Today we are specifically going to look at molten electrolytes. As we said, an electrolyte is a substance which can conduct electricity in either molten form or solution form and is decomposed in the process. Meaning that we have two types of electrolytes, the molten ones and the ones which are in solution form. Today, let's start with an example, and we are going to start with lead to bromide. Lead to bromide, which is PbBr2. Lead to bromide. Lead to bromide is a white crystalline substance. It can melt when heated at a very high temperature, but it is slightly soluble in water. Meaning that if you want an electrolyte out of this substance, it is always easier to have it molten than to dissolve it in water because it is sparingly soluble. When you melt it, you are trying to break the bond that is between lead and bromine to produce two ions, the lead 2 ions and bromide ions, which are in a liquid form because they are molten. You form 2 ions, only 2, no other added ion. We are looking at electrolysis. How does this substance conduct electricity? Let's have a setup. Let's have a setup of the experiment we're going to use. Have a battery, as usual. So, the battery connects the switch to the electrodes and back to the battery. We make sure that there is presence of heat. We must melt lead to bromide. Now, assume that you have set up this experiment, but this is not molten. If it is not molten and it is crystalline, you have just dipped these electrodes in the solid lead to bromide. What do you expect to see? What do you expect in the experiment? If this lead to bromide is used and you complete the circuit, there will not be any movement of electricity. When electrons move, they cannot go beyond this point. Why? Solid lead to bromide does not contain ions. It is not an electrolyte. It does not contain any free and mobile ions. Meaning that when electrons actually reach here, if at all they come anyway, They can't cross. They have no bridge that will connect them this side. But the moment you hit this solid and it becomes molten, if it melts, then you have broken down lead to bromide to form lead to ions and bromine ions. And therefore, these will be independent of each other. They are free. They can move. Therefore, they will help electrons to cross and so move through this electrode back to the battery. An indicator that the current will flow in the opposite direction, and so electricity will have moved. Can we label these electrodes? At least you must be having that information for now. If this is the positive end of the battery, then this one is the what? This one is the anode. It is positively charged. Let me put the positive here. And this will be the cathode because it is connected to the negative terminal of our battery. So, there is caution. You must be conscious here. In the experiment, we shall produce lead and bromine. Therefore, you must be cautious of the electrodes you have used. They should not be reactive to any of the substances you expect to get. These should be made up of unreactive substance. You can use graphite or you can use platinum, the inert conductors of electricity. The moment you use the electrode that can react, definitely to react with your product and you will have false results. So it should be graphite on both the anode and the cathode in order to avoid the reaction with the product expected. What will happen? What happens? What happens? Lead two ions are positively charged. Bromide ions are negatively charged. From kinetic theory of electrolysis, the positively charged ions will move to the cathode, the negatively charged electrode. Therefore, they will go in that direction. You shall have lead two ions going there. The lead two ions will move towards the other side. And then bromine ions will move towards this side. There will be orientation of these ions. Since like charges repel and unlike charges attract. Meaning that lead two ions, let me use symbols, lead two ions move towards the cathode and bromide ions move towards the anode. When they reach there, what happens? Still from kinetic theory of electrolysis, there will be discharge. There will be discharge. Discharge means loss of the charge. How will this discharge take place? Lead two ions will gain electrons to form lead. But when you look at lead two ions, it shows you that it is deficient by two electrons. It is missing two electrons. Possibly the ones it lost during bonding with lead ions. An indicator that it will have to gain two electrons to form lead. And that will happen at the cathode. An indicator that if this is a gray metal, we shall have a gray coating around, we shall have a gray coating around the cathode. Another discharge will take place. The bromide ions will get discharged. We said in the last lessons that at the cathode, discharge is always by gain of electrons. In other words, it is always by reduction. Whereas at the anode, discharge occurs by loss of electrons. An indicator that this one will end up forming lead, which is the bromide ions will form bromide atom and electrons that it will have lost. But remember, we said that this, since it is a gas, it is unstable when it is an atom. The different atoms end up combining together to form a molecule, which will be in gaseous state. So if this is a reddish-brown gas, it means that we shall end up seeing bubbles that will be evolving, that will be coming out around this electrode. What was a crystalline substance, a white crystalline substance, has ended up decomposing into two substances. It has formed a gray coating, lead, and reddish-brown gas, bromine. So, electrolysis has actually taken place in this electrolyte. Remember that if this electrolyte is not molten, no electrolysis can take place. Good. Can we try this question? And after trying it, do not forget to send the answers, to send for us your findings on our contacts. Electrolysis of molten sodium chloride. Molten sodium chloride. Please make sure that the emphasis is on that word. Describe. You can use your own flow. You can use your own findings, your own order, and you describe for us how electrolysis can be done on molten sodium chloride. Do not forget to send us your findings. Be safe. Make sure you continue learning with us.